Thank you so much, Michael, for chatting to me today. I wondered if you could give me just a high-level overview of your creative career so far, before we get stuck into our questions.
Sure, no problem. So, my name is Michael Chang, and I've been working in the creative technology field for about 25 years or more. I graduated UCLA Design Media Arts program, where we learned interactive media, we learned 3D animation, we learned just like old school print and branding. And I was always had an interest in software engineering as well as simultaneously the same time animation. I do wanted to become a Pixar animator when I was a
Oh,
child, um, and it never really panned out. Mostly because my focus was split like all over the place.
yeah,
So what I did was during college, I spent a lot of time trying to make things animate using code because every time the animation would happen, it would be different, it would be unique. And I thought that this is kind of like bringing something alive. And to me, this has like been one of my passions throughout my entire career is making something interactive and making it come alive and also giving it to people so that they can play with it.
that's a beautiful retelling of your background. Thank you. What we were going to look at today was some of the demos you've made with Gen AI tools.
Totally. So just recently, was specifically with Gen AI. I feel like Gen AI has changed quite a lot of how we make um, creative code projects. And this is one of the projects that I've been working on over the weekends, nights and weekends. I think in all this took me about 5 hours or so, like total maybe like half of the time I've been sitting on my couch doing this,
Yeah.
which is actually quite amazing. I load the cool version, the one that was shown recently by Demis on Twitter.
And this is Google AI Studio that you've used to build this one in.
Correct, yeah. I'm gonna wait until it spins up and then I'll talk a little bit about it.
How are you finding Google AI Studio? Is that your tool of choice at the moment?
I would say it's a good starting point to explore ideas.
Hmm.
There's a lot of like probably high level concepts that I want to explore, but I don't want to like dive too deeply and making sure because a lot of the times, you want to go with breadth versus depth. You're like making a decision between how many different kinds of ideas and how widely the idea is like
Yeah.
to explore versus how deep you want to explore that idea. In this particular case, I first started with a this project. My intention was to create a city generator, and the idea behind city generators is this practice or this hobby goes back by quite a number of decades, right? People have been trying this kind of thing for a long time, and basically what it is a way to use some kind of formalized logic to and first principles to create a city just based on rules. So, what are these rules? In this simulation of a city generation of how a city comes to be, first we need the terrain, the topography.
Mhm.
So, this that you're looking at is a relief map and using false color, of course. The blue is the water. You can see that there's a river running through, and there's some height, some elevation. This is probably a mountain. This isn't very realistic, of course. In real world, there's like erosion and all that stuff. But here, this is just a simplistic toy model of a terrain generation. And here in the bottom are a bunch of buttons. And each of these buttons is a step in the simulation of a city emerging from basically nothing. The very first step is creating a terrain. And so this is randomly generated, right? It's using math. And I can click this button a couple times and it would give me a new terrain every single time. So here I'm just going to click it for a couple times until I get something that looks pretty interesting. Mainly looking for maybe mostly a mountainous terrain with like one river running through because like, let's just pretend it's like London or something. Okay, so I'm gonna settle on. Let's keep going. This is pretty addicting, like procedural generation. It's kind of like a slot machine where you just like click and a new
Yeah.
cool comes out every single time. Okay, so I think this is kind of dynamic. There's a mixture of water and land. The next step in my simulation is we're because in figuring out how cities develop, you have some kind of principles about where do people congregate, where do people live. In the prehistoric times, people do fishing and they do farming, and this is kind of where population centers are. And you could kind of simulate this by saying, okay, well, where are the water? Where's the water? Where's the flat terrain? Where are people most likely going to settle? So we can make some inferences about that, right? We can design a heuristic that says if you're near water and you're near land, likely probably a population hub. So this is
Yeah.
what the second step does. So here we're seeing this like outline view, this X-ray view. So we only see the outline of the water. And each of these big circles are hubs. And these hubs are like, maybe people live here. Let's pretend that they are. This isn't like a population simulator or anything. It's just a abstraction of an idea. Here, there's smaller and smaller circles that go outwards. And so we're simulating sort of secondary tiers of population centers, right? Like,
Yeah.
oh, maybe this is like a foresting area, or maybe this
Hmm.
is a fishing area. And then there's the little yellow squares here represent how people might enter this simulated map. Because this map doesn't exist in a vacuum, there's probably outer world outside. And so we probably need to think about that a little bit. All right, I'll just pause there. Any questions so far?
Makes sense so far. I suppose my question would be, how did you prepare the prompts, and how did you research all of these things about how populations grow? Was that using AI tools as well?
They are intuition based guesses at what things, how things could work.
Yeah.
And I did work with, in conversation with Gemini, try to develop some of these ideas. So
Yes.
for example, I would actually ask it like, hey, like how should we simulate population centers? You give me some ideas. And then actually we would work together, go back and forth and try to figure out, okay, maybe this is a good solution. Um, I'll show you the concepts tab last, but this is a very important part. On the top right hand corner of the screen, you see this. I'm trying to make it a little bit bigger. There's this little concepts tab here. And that's where I cooperate with Gemini to figure out what features we want to build. And one of them is kind of like figuring out where population centers could be.
Great.
Yeah. Okay. So the next step is, well, people need to move from point A to point B. And when you look at a map, you pretty much predominantly see roads, right? We think of cities as like a structure of roads with like a bunch of buildings in between them. So this is one way to simulate that. This isn't the only way cities form, but roads are very important. Infrastructure. So we're gonna say, okay, pretend that there's is some random chance that a person or a group of people start their journey from one of these hubs, and the random distribution is based on how big the hub is. So we roll a dice, and it's most likely going to land on the big ones, but sometimes it'll land on the smaller ones. And then they're going to pick a random destination. And again, we use the same heuristic. So maybe the big ones will travel more likely to the big ones, or
Hmm.
maybe the big one will travel to the map exit. So we use, well, I'm using this basically an algorithm borrowed from like flocking simulation, right? How do birds or ants move?
Hmm.
And here in the simulation, I literally call them ants. So
Yeah.
I create hundreds of little ants that are marching along these roads or these paths. It went by a little bit quickly, but what happened initially was several ants traveled out from a hub, and they pick a location and they walk towards it. And every step they take, they leave a little cookie crumb, and we connect the cookie crumbs to make a road. And there's a little bit of like rules decision making about like, okay, if you cross another road perpendicularly, maybe there's a 75% chance that you'll survive crossing that road. Let's just to keep things interesting, because at the end of the day, this is not like a scientific
Yeah.
like software. This is to make art. And so there's some artistic decisions here to be made about, well, how straight should the roads be?
Yeah.
How often should they curve? There's a cool little detail here that you might notice, which is all these little arrows, the colored arrows behind in the background here.
Yeah.
It's like, yep. So this is called a flow field. And a flow field is essentially a grid of arrows that point a certain direction. And you can think of it as like wind, but it's not moving dynamically, it's just stuck in place. This flow field influences how the ants would like to travel. So this is simulating the uh, the tendency for roads to be traveling on flat terrain. So here I'm overlaying the elevation map with the flow field. And you can
Ah,
see like I'm it's creating flows around the contours of the mountains and also avoiding the shorelines. So this is creating a tendency for these ant travelers to stay on straight paths or maybe perhaps follow the curvilinear paths of these mountains.
wow. Yeah, that's so cool.
And so the next step here, let me toggle off the elevation map real quick. Okay, actually, I should step back one more a little bit. There are different kinds of ants because I wanted different. If you only had one type of behavior for these ants, the city would look quite linear. It would just be a lot of like kind of straight lines and sometimes curve
Mhm.
and sometimes go through each other. I wanted there to be, and this is like another artistic decision, to have ants sort of circle around hubs to kind of create this, like Champs Elysees like style
Yeah, nice.
ring roads, right?
Yeah.
Um, and this isn't like super duper realistic, but I just wanted that because it's cool. Um, and there's other ants that sort of hit a river or perhaps start their life on a river, and then they look ahead in their direction and say, "Hey, is there another road on the other side of the river?" And they'll try to build a bridge across. So this is what you're seeing here. It's a little bridge builder ant. There's a little bit of heuristics about like, oh, you shouldn't build a bridge too close to each other.
Yeah.
It's not perfect all the time. Sometimes it builds bridges like perpendicular to a shoreline. It doesn't make a whole lot of sense, but this is pretty rough. Okay, so the next step, next is called structural discovery. And here we've basically created a bunch of 2D lines, but this isn't very useful if you want to fill in these large gaps with detail. So here, Gemini's helped me create this algorithm that detects shapes, like enclosed shapes. And so here you can see them highlighted, and I can even mouse over them. And we can sort of see the area that this shape encompasses, and even sort of the general arteries of the outline of this block, if you will. And that's very useful to us because in the next step, I want to create this Manhattan style grid overlay so that this block, oh, it's too big. Let's actually subdivide that so that now there's a
Mm.
little bit of like brickwork style shape inside it. Again, this is artistic. There's a random chance that any particular shape will get this. And in fact, the grid isn't even perfect on purpose. There's like a little bit of curvature to make it a little bit more organic.
Yeah.
All right. And then the final step before we get to, a lot more AI generated stuff. This is all pretty classic, computer graphics technology so far. This is not the AI hasn't even come into this, right? AI has helped me program the core code of this, but when it's running, it's not AI yet. Um, so
Okay.
anyway, there is one more step before we get to the A part, which is traffic simulation. So here we see all these roads, but they're all of equal importance. Nothing is really a highway or a main road or like what you think of as like Main Street USA or something like that. And
Hmm.
so if I click on traffic simulation, what it's doing is it's taking the hubs from earlier and it's making a little trip, like it's simulating a Google destination, like a Google Maps trip to see, okay, if I get from A to B, what is the shortest path I have to take, and then take that path, and then we're gonna make the roads a little bit wider every single time we take the path. And here we get this cool visualization of like, okay, so the city centers are here. Let me like actually turn this back on. And so in order for you to travel from here to here, you have to go through this bridge, you have to go through this route.
Yeah.
And so this route becomes very popular. And so it becomes really, really thick.
Yeah. That's so cool.
And then we want to name everything. So there's a lot of different features, basically like terrain features. For example, this lake, what is it called? This district, this hub, what is this called? And in fact, we can even get down to the naming of bridges, right? Like this bridge, what is this bridge called? And so here we're actually using Gemini to say, okay, we have a list of hubs, we have a list of bridges, we have a list of bodies of water and a bunch of districts. We also know on the map if they're north, south, east, or west. We also know if they're close to water and how big the hub is. Using that information, please generate me a place name for each of these features. In addition, use plausible sounding names because Gemini tends to make like, it sees this and goes, oh, you're making sci-fi. So like it likes to make sci-fi names. So
Yeah.
it comes up with like a name like Vector or something. And it's like, no,
Yeah.
like get rid of that. So I've instructed it to be inspired by London, New York, or Paris names. Okay, so that's just another artistic choice here that I'm making. So by clicking 7 here, you'll see in the background is it's rendering a high resolution relief map of the terrain that you saw earlier. So what you're going to see under the map right now is like sort of like really refined pixels of the topology. But in addition to that, right now it's talking to Gemini and saying, hey, like make me those city names. It returns it to me in the JSON file and then I'm unpacking it and say, okay, which of these places did you name? And yeah, here we go. So one of the hub earlier that we saw is called Founders Point. This one is called Upper East Column. Hey, it's on the east side and it's the upper side, so that makes sense.
Yeah.
uh, this lake is called Silver Reach, St. Jude's Cross. Okay, and you can see like if I zoom in here, each of these districts are also named Saffron Lane, Decay, or Key, I guess it's pronounced, um, Appleton, and the bridges should also be named. This is Kingsway's Bridge. Cool.
Very cool.
All right. So the very last step, and this is inspired by one of my colleagues who basically took this screenshot that I had in one of my trailers for this and put it into Nano Banana and output a 4K image, a satellite image. And I thought that was so cool that I implemented this feature. So here in step 8, we're gonna send this whole map, but without the text, and with the road network, it's going to send that image and say, "Hey, Nano Banana, turn this map into a satellite image." But oh yeah, so sometimes yeah, I have to regenerate it a couple times because I think yeah, this API key is getting hit real hard. It's actually running out of quota, so
Yeah.
this will take a couple tries. So yeah, feel free to cut this part out of your video.
It is making
Uh,
an entire city slash multiple cities, so I feel
I
like
know.
that's fine.
What more can you ask, right?
Yeah, it's
Yeah.
reasonable to struggle with that.
And it's not guaranteed that the first try will look good either. Sometimes it makes like really realistic or satellite maps, and I find that those to be a little bit off-putting because they're like it's a bit spy satellite voyeurism kind of aesthetic.
Yeah,
Whereas there's sometimes it'll make the artistic decision of making a more game-like aesthetic with like 3D buildings and stuff, and those are the
yeah,
ones that I like the best. Yeah.
yeah. And could you prompt it to do that in a particular style, or do you prefer to let it see what happens?
That's a good question. Here in this particular case, the only instruction that I told it to was to make it intriguing, complex, and beautiful without any other qualifications like making it look like a game or anything like that because I
Yeah,
wanted to keep its creativity a little bit. Once it's finished generating the satellite image, it would create an image like this. And
yeah,
you can see how like all the different parts of the
yeah,
city are named and you can sort of zoom in. And it does actually quite a decent job of matching like the road layout to the road layout that I generated to actually like highways and roads in the fictional city. And another thing that's really cool is that you can sort of pick a location and say and tell Gemini, hey, take a photo, like an aerial photo from this location, and it would actually pretty accurately
Wow.
generate like an drone photo basically, and it would match like the topography and the road layout and sometimes even specific architecture that's like there in the image.
Wow. This is amazing. Like the fact that you've thought to do this and then managed to actually put something together in a few hours, just shows how impressive the tools are. And I think like something like this, thinking about practical applications like town
Mhm.
planning, city planning, modeling, like all of that types of uses would be very interesting to apply this type of technology to it.
Totally. Or, perhaps you're shooting a film or using, AI and you need to create a new city or a new set, right? It's
Yeah,
like how expensive is that
yeah,
in terms of CG, right? Like modeling all these buildings. I've
yes,
done that before. I've actually like modeled 3D cities by hand using 3D software, and
yeah,
it sucks. It's very, very slow.
yeah.
Um, and I've built games that are like this, that it's also very time consuming, right? Every single asset you have to make. Sometimes if you just want one still image, this is enough. You don't need to explore it in 3D 100%. Um, I want to show you this screen. This is the concept screen. And remember earlier I was telling you about how I was asking Gemini, hey, like, let's figure out how to get the hubs in the right place. Well, we would do it in this laboratory. This is called the concepts page. And here, I literally began the project by saying, hey, Gemini, write me a 2D vector library. What is a vector? Vector is just a representation of a line and a direction, like a point in space and a direction. And you can use vectors to sort of create triangles. You can use vectors to add and subtract and then figure out distances. This is the foundation of math that we're dealing with. And then we would use this as a first principle, as a starting point to build more and more complex concepts. For example, um, this shape, like a shape grid. So it's like here I'm mousing over, and Gemini created this demo for me. This is to say, if I am in this grid on the top left, what shapes is it overlapping?
Hmm.
And we can use this to sort of optimize the mathematics in the program to not make it so slow. This is an optimization strategy so that we can say, oh, like if you're doing a mouse hover like I did earlier, we don't have to detect the entire map to check every single shape. We just have to check that one grid that your mouse is in. So this is an optimization strategy. Do you remember the labels that were like the text labels that were hovering on the city earlier?
Yeah.
Well, the text labels would often come back, like we would put the text labels, Gemini and we would put the text labels in the center of the shapes, for example, in the center of the bridge, in the center of the district. But this isn't always a very good strategy because a lot of the times the text labels would overlap each other. And so here, this little algorithm that Gemini wrote does a relaxation step. It's like, oh, the labels are overlapping. Let's do a little bit of physics and like push them away from each
Hmm.
other to make
Mhm.
them look really good. Um, this is the river generator. So given a 2D topology, you can see the dotted line here. It represents the spline of the river, like a 2D
Yeah.
arc, and it will like physically carve into the topographic map a river. So it's like simulation of a river. This is a um, this is a capsule detector. It's like you have these 2D shapes that are like kind of like a pill, and can you detect when one is overlapping the other? And this is useful for like when we're creating roads. We don't want roads too close to in parallel to each other. We want them to be a little bit spaced apart. This is used in that. So all these tiny little problems Gemini helped me to solve. I kind of know intuitively and also by experience, solving these problems is really important. So
Mhm.
at a certain step in the simulation and like in the procedural generation of the city, I'm like, okay, we to make this look more realistic, I probably want some kind of flow field to go around the terrain. So I've asked Gemini, hey, make me a flow field simulation based on our existing technology. So it already knows how to generate a 2D a terrain map because we've proven it out here in this screen. So it would make me that first, and then it would make me a flow field, and then it would put the agents on there to give me a simulation of how they would perform. So all these tiny little problems, Gemini helped me to solve one at a time, and then there are times when it couldn't solve a problem. For example, here, remember the arteries and the city blocks I was talking
Yeah,
about earlier? I was like, okay, there's a certain shape that it would just the algorithm just kept bugging out on. And I was saying, okay, please make me a teardrop shape. And Gemini doesn't know how to make that in terms of math. It just was bad. So I said, fine, let me draw it. You make me an editor so I can draw this. So it made me this little editor that I can click, and I can say, okay, I'm going to make this, and then I'm going to copy this data back to you, and then you go ahead and put that in the test, and then make the algorithm work.
yeah,
So there was a lot of like collaboration here. So many times I would literally just send it the screenshot of the generation and go, what's wrong with this? My roads are too curvy. Can you
yeah.
make this like a little bit straighter? And it would think, okay, well, that's probably because our algorithm is causing the ants to turn too much. There's no forcing function to keep it on a straight line because roads tend to be straight unless forced to act. And so it would actually go back and rethink this and then make the algorithm look better. So that's amazing.
It really is amazing. And I think having a space in the UI that you can go and understand all of these different decisions and the problems that you've been solving together, I think is also really nice. I've seen a lot of designers having some space, especially in AI Studio, to do some of this tweaking and like to surface how the AI is helping them and how it's working and how it's thinking about the tool so that they can then go and tweak it. I think this is a really good example of that.
Yeah, exactly. I think a lot of artists, right, they think of in terms of like, well, in order to achieve my art, I probably need to do it in a couple different steps, right? If you're making like
Yeah.
a sculpture, you need to like find a reference right, just like think about the concept. You need to like find the right material, so there's all these different steps. If you already know how to do that, then Gemini can help you make those steps faster. So this is a case where I kind of like have the steps in my head, but each of these steps are extremely time consuming, right? Writing this little algorithm, it's going to take me forever. It's going to take me
Yeah.
weeks. But it just did it because it knows how to do it. And
Yeah.
I'm the artist here assembling these components together.
So thank you so much, Michael. This was really interesting and very impressive what you've been able to do with these tools already. Do you have any ideas or big projects that you want to try next?
Yes. I'm currently working on a historical map generator based on plate tectonics. So,
Wow.
starting from how the earth moves and then how kingdoms rise and fall. And I think that would be really interesting to see their political boundaries and draw some cute castles. I think that's my ultimate goal, is to draw like, so like a role playing map like Lord of the Rings.
That would be amazing. I can't wait to see what you do with that. Thank you so much for your time. I really appreciate it.
No problem. Thanks, Courtney.
Thank you.